Welcome to Mechanics Year 1, Chapter 11.4, where we'll continue to investigate variable acceleration. Now, previous lesson, we looked into differentiation. So this one, we look at integration. Differentiation, integration, they're like evil twins together. So notes, displacement, velocity, acceleration can be expressed as a function of t, f of t. So we know like v equals u plus at, s equals ut plus half at squared. They are all functions of time, or even, it could be written as a quadratic or cubic equation like this one. V equals 2t squared minus 14t plus 20. So it's not only bound between v equals u plus at, that kind of kinematics formulae, even though they could be a function of time. However, what we're looking at here are a bit more like a real life, like a curve, rather than a constant acceleration, a straight line. Okay, so we in previous lessons we look at variable acceleration cause differential relationship between three variables s, v, and a. So we can use a little diagram or a flow of working out to show the relationship between displacement, velocity, and acceleration. Okay, so displacement is s, velocity we use v. Now there's not a final velocity, we just use v for velocity, a acceleration. So last lesson we look into this one. So if you have displacement to work with velocity, we know v equal ds by dt. And from velocity to acceleration, we know acceleration equals dv by dt. So going this way is differentiate. Okay, differentiate. So going backwards, you could imagine it will be integration. So v equals the integral of a dt. That means we're integrating a with respect to t, then we get velocity. And backwards, okay, so s equals integral of v dt. Going upwards is integration. Now, one way to remember this is if you remember a diagram like this, you can remember that the end of the arrow is where you start the formula. For example, displacement pointing to velocity means the formula starts with v equal. And because it came from displacement going downwards, therefore ds by dt. Or now this one here, from acceleration to velocity, the end of the arrow is pointing to v. So the formula start with v equal again. And then now because we're going upwards, so integral of a dt. Like this one, v to a means a equal. Going downwards means differentiation. Now these four formulae are something you would have to remember. Okay, so you might be wondering, when do we use it? It's quite simple. When you see a question that gives you in terms of like a quadratic or cubic equation with v, s, and t, you know something to do with these four formulae. Okay, just one thing with integration. Okay, we know with integration there's a plus c, so you might write down. Okay, so to find the plus c value after integration, we need to use what we call, use boundary condition. I'll explain what it means. You will see an example given by the question. Okay, sometimes hidden. Right, so to find the plus c, we need to use what we call boundary condition. Right, so let's have a look. Example, a particle is moving on the x-axis. At time t equals 0, the particle is at the point where x equals 5. The velocity of the particle at time t seconds where t squared equals 0 is 6t minus t squared meter per second. Now, as soon as you see 6t minus t squared, you should be thinking about, this chapter 11, about variable acceleration, differentiation, the integration. Find an expression for displacement. So let me test you. Okay, we want to find displacement from velocity. So which formula should we use? So we want to find displacement means we want to find a formula that starts with s equal, and the other one with s equal is s equals integral v dt. So it has to be one of these four formulae. Okay, so s equals integral v dt. So s equals integrate 6t minus t squared dt. So let's integrate. Integrate means add 1 to the power, divide by new power. And don't forget the forgotten child. I used to call them plus c because a lot of students will forget the plus c. And then 2 and 6, 3t squared minus t cubed over 3 plus c. Now, we need to find the c value. So the c value, we can find the c value in here. So this line is what we call a boundary condition. So this is a boundary condition. It essentially is a condition or information that is provided to you that can help you find C. So boundary condition in here means t equals 0, s equals 5. All right. So when t equals 0, s equals 5. Sub it in. 5 equals 3 times 0 squared minus 0 plus c. And you should get 5, c equals 5. So if c equals 5, you have to rewrite the equation. T cubed over 3 plus 5. Okay? Right. Can you not write a final line? You can't because the question needs an expression for displacement. So if you don't write a final line, you will lose the last mark. Part B, find the distance of the particle from its starting point when t equals 6. So part B, well, when t equals 6, right? When t equals 6. So when t equals 6, so s equals to 3 times 6 squared minus 6 cubed over 3 plus 5. Now, just be careful, your s and 5 are quite similar, like mine. Just be careful when you write out. So s, you get 41 meters. But because we start with 5 meters, therefore, distance traveled equals 41 minus 5 meters, which is 36 meters. Okay? Right, one more. A particle travels in a straight line such that its acceleration, a meter per second squared at time t seconds, is given by a equals 6t plus 2. When t equals 2 seconds, now this is not quadratic nor cubic nor anything weird. However, how often do we see acceleration given in an equation? Then again, a cue for you to think about differential integration. When t equals 2 seconds, the displacement s is 10 meters, and when t equals 3, displacement is 38. Now, as soon as you see this, hopefully you do understand these are boundary conditions. So this one means t equals 2, s equals 10. All right, and one more. This one, t equals 3, s equals 38. Right, it will come in handy. Find displacement when t equals 4. Now, question for you. How do we find displacement from acceleration? Now, note this is not Suvat, so we don't use Suvat formula in here. To find displacement, we need to use s equals integral v dt. However, we don't have v. All right, so here we go. Okay, so we have a. Okay, we need to first find v, and then we can find s. So to find v, we need to do v equals integral of a dt. So let's do that. So v equals integral of 6t plus 2 dt. So v equals to 3t squared plus 2t plus c. Right. Are we able to find c, the value of c in here? Now you look at these two boundary conditions in here. They are given in terms of t and s. So we don't really have a boundary condition for v. Okay, so we have to keep the c. Right, so let's go on and find s. So s equals integral v dt. Now, can I ask you, okay, do you write a note in here, okay? Why can't we find c in here? Okay, why can't we find c? Okay, answer this question here. Right, I have just explained probably 20 seconds ago. Right, anyway, so s equals integral v dt. So let's integrate. So s equals integrate 3t squared plus 2t plus c dt. So we integrate it. So then s equal, add 1 to the power, divide by new power. Now what about c? When you integrate c is a constant. So when you integrate a constant, you get ct. And then plus, normally we'll do plus c, but because we've used up c, let's use d. Right? So let's simplify a little bit. T cubed plus t squared plus ct plus d. Now this is where we can use the boundary condition. Okay, so the answer to the previous question, why can't we find c in here, is because the boundary conditions given do not link c and t together. Do not link, sorry, v and t together. Are not given in terms of v. They're given about s. So in here we can sub it in. So when t equals 2, s equals 10. So we use our first boundary condition. So when, oops, bit glitchy. When t equals 2, s equals 10. So sub it in. So when t equals 2, so 10 equals 2 cubed plus 2 squared plus 2c plus d. You can simplify the algebra in here. You get minus 2 equals 2c plus d. Right? Next one, the orange one. When t equals 3, s equals 38. So sub it in. So 38 equals to 3 cubed plus 3 squared plus 3c plus d. Simplify the algebra. You get 2 equals to 3c plus d. Now, whether you want to do it manually or not, or using a calculator, in A-level maths, you don't get any marks for solving to show how to solve a linear simultaneous equation. So anyway, so once you do simultaneous equation in here, simultaneous equation either by calculator or by manually. Okay, I'm going to skip the calculation. Again, c equals 4 and d equals to minus 10. Now, if you don't know how to use a calculator with simultaneous equation, you can get a menu and then go to where you normally solve quadratic. You will see a simultaneous equation function. So click in that one and you'll be asked to put in the coefficient of the two variables and the constant term. All right, you should get c equals 4 and d equals minus 10. Therefore, now what does the question ask? Now you've done so much working out. Let's read the question. When you're lost, when you forgot what you need to do, you know where you're heading, read the question again. The question wants to find displacement when t equals 4. So the question wants displacement. Therefore, I think it makes sense to write the displacement formula again. So s equals t cubed plus t squared. Oops, my plus becomes a t plus ct plus 40 plus d minus 10. When t equals 4, then s equals to 4 cubed plus 4 squared plus 4 times 4 minus 10. And then put in a calculator or mental maths, 86 meters. All right. So part B. Find the velocity when t equals 4. Find the velocity. To find the velocity, you need a velocity equation formula, which is what we've got in here. V equals 3t squared plus 2t plus c. So part B. So V equals 3t squared plus 2t, now plus c, which is now plus 4. When t equals 4, so V equal, not S, V equals to 3 times 4 squared plus 2 times 4 plus 4. 4 times 4 is 16, blah, 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 60 meter per second. Okay, if you can't do it in 2 seconds, your mental math's too bad. Right, so yeah, all right. That's what we do. We'll find displacement. We need velocity. To find velocity, we got acceleration. So v equals at integral of a dt to start with, and then to find s from v, we can do s equals integral of v dt. Sometimes you're given a simultaneous equation like this. You sub it in, find all the boundary conditions. The thing is, you have to understand where the boundary conditions given by the question and make sure underline it. And as the quicker you realize it's a boundary condition, the quicker you probably understand. Oh, it's an integration question. Right. So press question 1. All right, pause video, have a go at the question. When you're ready for the answer, you can press play. Right, this question is actually quite a tricky one. The answer is 20.32 meters. I did give you a hint because it's a tricky one. Now I'll show you why. All right, so if you haven't drawn a graph, you got it wrong. Okay, I'll show you what happened in here. So let's draw a graph of the VT graph. Okay, so VT graph. So let's draw a graph. So v equals 6 minus 3t squared. So when t equals 0, v equals to 6. When v equals 0, you get t equals to, when v equals 0, you get t equals to root 2 or plus and minus root 2, but you can't have negative. So what's happening in here? So that the graph looks like this. It's a negative graph, so start from 6. Right? So we start from 6, and this is root 2. Now, what's the problem in here? The problem is we want to find the first 3 seconds. Now, if you do root 2 is 1.41-ish. That means at 3 seconds, which is here, the total distance traveled will be broken into 2 parts. So that's part 1. And then you also have part 2. Right? So the total distance traveled will equals to, let's call this part 1, part 2. So plus part 1 plus part 2. Now, why do we have to do so much extra from part 1 to part 2? The reason being is, okay, so why 2 parts? Because part two, let me use green just to color code it because part two, okay, is under the x-axis, which means the distance is negative. So therefore, that's why we have to do two parts because it's become negative. Okay, if they ask you for displacement, you're perfectly fine, but because the distance, that's different. All right. So the distance, I have mentioned so many times the difference between distance and displacement. Distance is displacement is where you count from the where you started right at the beginning to I don't care where you ended up, where you're going in a journey, but we just count the final position where you're standing, okay, compared to original. So let's say you travel 100 meters, okay, 100 meters to the right, and you come back 50 meters, okay, then let's use a different number, 40 meters, okay, then your displacement will be plus 60, okay. However, for distance, you have actually traveled 100 plus 40, which is 140 meters. So that's the difference. All right, so that's exactly what's happening in here. You have traveled somewhere further away, and then you start to come back. So the displacement wise, there will be something taken away. But you want to find distance. So to find distance, you must add the two, do it separately. So let's do part one. Okay, so to do part one, you realize to do part one, you will need to integrate to find displacement. So S equals the integral of 6 minus 3t squared dt. And actually, it's from 0 to root 2. So S equal, you can do 6t minus t cubed. Now, we don't need a plus c in here because we are integrating with range. So S equals 0 to root 2. So S equals to, put in a calculator, you get 4 root 2, which is same as 5.66 meters. And part 2 is when you're integrating, S equals integrate from root 2 to 3 of 6 minus 3t squared dt. So S equals to 6t minus t cubed from 3 root 2. Now, if you put 3 in there, you should get minus 9. When you put root 2, you get 4 root 2. So you get S equals minus 14.66. It's negative because underneath the x-axis. So in here, it's negative because under x-axis. So therefore, the total distance traveled. So therefore, total distance traveled equals 5.66 plus 14.66, which is 20.32 meters. Okay, we ignore negative, just like finding area under the curve. Okay, we ignore the negative. If you have no idea why do we ignore negative, you can go back to pure one integration chapter about finding the area, chapter 13.7, I think. Right. So you can have a go next one. Okay, pause the video this time. Okay, for the values of questions A, B, and C. Now part C, again, something similar to what we just did. Have a think about. Pause the video, have a go at the question. When you're ready for the answer, you can press play. Here are the answers. Okay, here are the answers. If you go right, well done. That's the end of lesson for you, I think. Yes. But if you don't, let's go through. Question A, find the values of P when it's instantaneously at rest. We talked about this last lesson. Instantaneous at rest means V equals 0. So question A, so we're given V equals to 2t squared minus 9t plus 4. When V equals 0, sub it in. So 0 equals 2t squared minus 9t plus 4. Put in the calculator. Again, you don't get any marks for showing how to factorize using quadratic formula, whatever. Just use a calculator. So you get t equals to a half or 4. Okay, 4 seconds. Part B, find the acceleration of p when t equals 5. To find acceleration from velocity, so we know a equals dv by dt. Okay, so a equals dv by dt. So a equals differentiate v will be 4t minus 9. So we want to find t equals 5. So when t equals 5, you get a equals to 4 times 5 minus 9. So a equals to 11 meter per second squared. Okay. Now part C, find total distance traveled by p in the interval between 0 and 5. Now this is where the answer in part A comes in handy. So when it says instantaneous at rest, it also usually means change in direction. In the previous practice question, we talk about the difference between the distance and displacement. So when you have a change in direction, then you have to calculate distance separately. Okay, I'll write down for you. Okay, when there is change in direction, we need to calculate the distance separately in each time interval. Pardon my writing. Interval. Wonderful. Right. So from 0 to 5, so distance, therefore the distance from 0 to 5, what we need to do is when you break it down into from 0 to a half, 0 to a half, okay, plus a half to 4, plus 4 to 5. Now you might be wondering, why is it a half and a 4? Okay, because from part A, okay, that's why these where the value is from. Right, so I'm going to call it 1, 2, and 3. So you take the point where it's instantaneously is at rest. You take these points as your time interval cut. Right. So what we'll do is we'll just work out distance from 0 to a half. So part 1, what we'll do is to find distance, we'll find displacement. So S equals integral V dt when you integrate from 0 to a half. Okay, so S equals integrate V. So what's V again? 2t squared minus 90 plus 4. So 2t squared minus 90 plus 4 dt. So S equals to integrate it 2t cubed over 3 minus 90 squared over 2 plus 4t. There's no plus c needed. Okay, so you sub in a half and sub in 0. So when you sub in a half in there, you should get S equals to 15.958 minus when you substitute 0. When you substitute 0 is, am I missing something in here? When t equals 0, p is 15 meters from the origin. Now, when you sub in 0 in there, you might be thinking S is 0. However, pay attention to the question. It says when t equals 0, p equals 15 meters. So we're going to use this information here. Okay, so therefore minus 15. Use purple in here just to color code it for you. This is where it comes from. Okay, so so this one not 0 because question has given information info. Okay, so you can use a pencil or whatever, link this when t equals 0, p is 15. Okay, so right, so therefore S equals to 0.958 meters. That's part 1. Part 2, do the same thing. Part 2, this time we're going to find S equals to, this time integral from a half to 4 of 2t squared minus 90 plus 4 dt. So S equals to 2t cubed over 3 minus 90 squared over 2 plus 4t of a half and 4. So when you sub in 4 in there, then you will get 5 over 3. And when you sub in a half, you get 15.958, which is, I know it's negative, so you'll get negative 14.292 meters. Therefore, distance equals to, ignore the negative, 292 meters. Right? That means it's traveling backwards. Negative because traveling backwards. Negative because traveling backwards. So when a question tells you instantaneously is at rest, that's when you do this for distance. That's how you cut it into different intervals, right? So part 3, last part from 3, from 4 to 5. So S equals This time we write 2t cubed over 3 minus 9t squared over 2 plus 4t from 4 to 5. Sub it in, so sub in 5 and 4, sub in 5, you should get 35 over 6. Sub in the 4, you get 5 over 3, which is 25 over 6 meters. Now this positive means it's going forward again. It's going forward again. It's positive because it's going forward again. Previous one in here, this one means going forward. Okay, going forward. Right, so what's the overall distance then? The total distance, therefore the total distance equals to 0.958 plus the 14.292 plus the 25 over 6, which gives you 19.4 meters. Now, if you do from 0 all the way to 5, you won't get this answer. Okay, so this question is slightly trickier at the end. But yeah, but most of the homework questions should give you a bit of fluency of the basic stuff, which we first did in examples, and then slowly moving on to the harder exam questions, where the last part, find total distance, that kind of question. Okay, and that's the end of chapter 11.4.